Welcome to Razor Labs Expert Series, episodes of interviews in which the company's specialists share insights into their unique experience in the fields of AI, digital transformation, Industry 4.0, product management, business innovation, and market disruption.
Thanks for having me.
Hi, Michael. Today we have a special guest, Michael Zolotov, the co-founder and the CTO of Razor Labs. Michael is 33. He is co-founder of 4 successful and thriving companies, Razor Labs, Axon Vision and Axon Pulse, and Compie Technologies. He has a proven record of transforming innovative AI ideas from theoretical concepts in the labs to products that make business impact and disrupt their fields. Michael has an extensive experience of developing cutting-edge AI solutions for various industries. He established an AI school that has trained over 50 engineers who are now successfully integrated into leading technological companies, and he was also included in Israel's Forbes 30 under 30 list. Michael was born in Ukraine and moved to Israel when he was 3 years old. Welcome.
Thank you.
Michael, so you have founded Razor Labs in 2016, and since then it has been quite a journey. Can you tell us how Razor Labs was founded, what was the original idea, and what Razor Labs is doing now?
So originally, Razor Labs started as an AI services company. We really started with the dawn of AI, really the first neural networks that were just coming out to the market. And our goal was to take this technology and transform it into real business applications. We had clients from the medical space, retail, defense, really everything. And our goal was to basically resolve their business challenges using AI. We've built some of the most complex models in the market. And because of the shortage of engineers and AI deep learning engineers, we actually founded the school, as you said, in order to keep up with the market demands and in order to scale up more rapidly. That's how we started. Roughly 2 years after the establishment of the company, we met by chance one of Australia's leading gold miners. And we were introduced for the first time to their challenges. Firstly, we saw what is how substantial is the cost of every hour of throughput, of every hour of production. We learned their equipment, we learned how they operate, and we understood that they had so much downtime that it was a huge potential for us to productize our offering and to choose, a specific sector and a specific product to really focus on.
Wow, that's incredible. So when you came across the pain in the mining industry and you decided to shift from services to a product company, you developed a unique approach. You looked at what was happening in the market, and then AI sensor fusion technology, AI sensor fusion approach came around. Would you like to speak a bit more about it?
Yeah, sure. So I think that even today, one of the key aspects of how we operate, how we go to market, how we establish the direction of our products is through domain expertise. So we have ChatGPT all around us. I think that most of us used it at least once. And I think that the key thing is to remember that while these tools are very helpful, it is very important to have the domain expertise, in this case, mining and condition monitoring domain expertise, to really form the path of what is the North Star, where are you aiming? And in this case, when we went and spoke to domain experts and we asked them, how do you diagnose equipment today? How do you know what fails or what is about to fail? We saw this huge variety of methods, and basically it very much resembled, how doctors work, right? So my entire family are doctors, so I have quite some intuition there. And when you go to a doctor, they have so many tools in their tool chain when they perform diagnosis, right? They can use MRI, they can use CT, they can use ultrasound. And it was very much similar in the machine space, right? You have ultrasound, you have vibration, you have oil analysis, you have thermal imaging, and so on. And we understood that there is no single sensor that really allows you to capture all the failure modes. And we understood really from the beginning that we need to really look at everything just like doctors do in order to perform the diagnosis. And that's how we came up with the AI sensor fusion, with combining all of this information. It was basically our means to get to this end of really covering all major, or comprehensively covering all major failures of the equipment.
That's incredible. Because before I met Razor Labs, before I joined Razor Labs, I met and worked with a few different other companies in predictive maintenance space in industrial applications, and the buzzword or the main focus was vibration. So basically, if you knew how to analyze vibrations of the machines, you would know how to solve the problems. But apparently, this is not enough, and this is what causes actually failures to repeat and keep happening.
Correct, and we can really go into even just several examples. Number one, some machines are just too slow to monitor with vibration. If you take, for example, trunnions of mills that are very common in gold, in copper, they're just too slow to really only use vibration. And in their case, oil analysis makes much more sense, as an example. And another, I think, very substantial example is looking at the material. Right, the material itself that goes through all the process chain, that's on the conveyors, that goes through the crusher, through the mill, vibrations just don't cover it. They completely disregard it. And you spoke a bit about the root cause. The material itself is many times the issue, the real issue. So if you have an issue with the material, maybe it's oversized, maybe it has clay, maybe it has a lot of humidity, whatever it is, it will cause cloggings, it will cause deterioration and so on. And you will, as you said, keep on replacing the equipment while this is not the real issue. And our way of actually monitoring the material is through the use of cameras. Cameras that look at the material, identify it, analyze it, extract really dozens of parameters from the material. What is its composition? How large is it? Alignment, spillage, and many other factors that are very important when you really look at everything all together.
Wow. So basically, before DataMind AI, Razor Labs' flagship product, came around, what were the methods of predicting failures by mining companies? What did you see before you designed the product in the field?
Sure. So we see several groups. It's not a single solution. I think that the most prominent method today is to just use SCADA. Basically, I guess all operators today know this phenomenon where you're basically bombarded by SCADA alarms. And SCADA is an amazing system for production and for monitoring your operation. It's not made for ConMon. It's not made for condition monitoring. And one of the disadvantages of SCADA is that it does not perform diagnosis of the machines, right? So it can for safety reasons, protect the equipment. That's why it trips it. It can stop the equipment, but it will not tell you, is it an issue of dead bearing, that oversized oil contamination, and so on. It's just not made
and
for that.
And it bases its forecasts or its predictions on historical data, or which other indicators? What does it base the predictions on?
So mostly it's based on just simple thresholds that are set by the operator, obviously based on dozens of years of experience of that operator. But they would be pretty simplistic. For example, overheating thresholds, over current, over torque, things like that. So they will capture obviously some of it's not like they capture the failures because they trip the machine. They cause the downtime in order to protect the equipment, but they will not diagnose the machine for you. And obviously, and that's the most important part, they will not let you deal with the equipment before it actually causes the trip, before it breaks down and stops, which is what we come to help with. They will not look at condition monitoring sensors that we use. They will not look at cameras. They will not look at the spectrum of the vibration, which is very important to perform the diagnosis. And it makes sense because they're just not meant for that. But today, I would say that they are by far the leading tool that are used by teams on site. And a different tool would be just, manual recording of vibration, of thermography, and so on. Maybe every month, every 2 months, depending on the site. And this obviously encompasses inside a lot of labor, right? I mean, imagine you're a person that needs to go through the entire site periodically. You cannot do it every day. So by definition, you will miss many of the fast deteriorations. But still, obviously, you'll capture some. And our goal is to automate that process. Our goal is to come to these amazing reliability teams and condition monitoring teams to monitor 24/7 the equipment and to basically direct their attention to this small portion that is about to fail. So completely, remove all that time wasted on looking at healthy equipment and only direct their attention to this, 2%, 5% that is about to fail and really needs their focus.
Yeah, it also seems like the ratio of maintenance is very hard to be calibrated properly. Maybe there's an over maintenance, and with manual under maintenance, and with manual testing also, it seems like there is a huge safety issue where the maintenance
Correct.
staff
You need to, by definition, you need to go to machines that are in critical conditions that might blow up, might erupt, whatever it is, on you while you're there, of course.
Not mentioning the dust and the noise and the environment, which is not ideal to be around. So we're talking about SCADA and manual testing, and are there any other predictive maintenance solutions that aim to automate that predictive and
So yeah, obviously there are many
process?
tools. Every company today can just go ahead and buy sensors. Many of our sensors are completely off the shelf. And basically you can buy sensors like vibration sensors and so on and install them. But then the question is asked, do you have, without the automation, how do you actually keep track of all that raw data, right? So now you have 1,000 sensors on your site. Who will actually look at them? Who will actually look at the spectrum of every sensor 24/7 to make sure that you capture that pattern? And many times these patterns are pretty hard to see.
Mm-hmm.
It's not always that easy, and putting simple thresholds are many times not enough. And basically that's where our system comes into place. It takes all the data from the sensors. Many of our sites, the sensors are already there because they've bought the sensors, as you said. In many other places, if the sensors don't exist, we just go ahead and deploy them. But basically, the offering is, let's take all the data, put it all together, analyze it, and basically focus your attention on this small portion that is about to break, so you can really focus on the right things on site. And that's what we do.
Going back to your analogy, this is what a good doctor would do. He would actually look at the entire spectrum of data and then decide, as opposed to doctors who, do like 1 or 2 testing methods, give you some sort of treatment, and then they'll see you come back to them after 2 months. And maybe the patients will opt to choose to another doctor because they want a better, more comprehensive treatment.
If you think about it, a good doctor, number one, will look at your history, at the patient history, because even if you take the same male, 35 years old, they've eaten different things, they've lived in different geographies, they had different environments. So all of these are taken into account, and they will look at the right testing methodology, whether it's, again, ultrasound or CT, whatever it is, based on what's happening to that person. So that's exactly what we do. We look at the history of the machine. We have the system has a preliminary knowledge of how failures for that kind of machine should look like, because we have seen plenty of mills and crushers and reclaimers and conveyors and fans, whatever it is. So it already comes pre-equipped with that preliminary knowledge, but it is looking specifically at that machine, taking everything into account.
So it seems like the mining industry is a traditional industry with their own ways and traditions and preferences on how to run maintenance and how to upkeep the machines. And it is quite obvious that DataMind AI is a very cutting-edge, innovative, modern solution. And sometimes there's a conflict between the two, implementing that solution. So how did you manage to enter the market, and what were the main challenges of introducing this solution to the users?
So it's a very good question. Basically, the answer is lots of trial and error, and I'll maybe speak about several features that we implemented exactly for that. So I would say that number one is building trust into the system. How do you do it? When we started, the system only performed diagnosis, right? So it got all the data, it diagnosed, that's the upcoming failure, that's the urgency, and so on. And the problem was that a real human being, when he or she looks at that system, they want to ask why. What did you see in the data? What made you believe that this is the diagnosis, just like you can ask any doctor? And we added a very sophisticated evidence algorithm that basically takes all these terabytes of data and from there choose this specific portion that tells you that's why. From all of the vibration, all of the sensors, all of the cameras, everything, that's the portion. And this, what we call evidence, is presented together with the diagnosis. So it builds very strong trust in the system. It kind of puts the customer, in the same boat with us, because we're basically together looking at now the same thing. And it also informs them better on the decision. They might say, okay, I got it. For me, it's less urgent or more urgent. So they're part of the loop. It's a very important part of the customer engagement methodology. That's number one. I can give another example, which is basically the simplicity that it takes to deploy the system. So we're speaking here about teams on site in dusty environments, people that are overworked, right? These are harsh environments. When we started, we were just a software company. And we saw pretty quickly that the data that we need is just not there. And a few years ago, we made this, it's not a pivot, but an enhancement, where basically we say to site guys, if you don't have the data, that's fine with us. We'll have our local teams go ahead and deploy it for you, connect everything, put everything right to the point that it's up and running. And a part of our pitch is that the moment we leave site, that's it. The system is up and running for them to use it. They log in, put their username and password, and it just works. And making it simple to implement, without any hurdles, without them requiring to calibrate it, to teach it, to train it, whatever it is, like other systems require from you, that I think has been massive in the adoption of the system.
Yeah, because you have so many responsibilities, so many things, and not even talking about shutdowns and unexpected shutdowns and all the hassles that those teams have to tackle, and then you come with a new system and with headache of learn how to use it. And in that respect, DataMind is extremely straightforward, extremely easy.
And you cannot add to their workload. You need to reduce their workload. That's the concept.
It's beautiful. So from what you're saying, it seems like you have spent a lot of time in the field, meeting the teams and
correct,
and breathing the dust of the mining sites.
Yeah, I think we've been to maybe near 100 sites up until this day. I think it's critical. I mean, getting to know the customer, getting to know the users, feeling their pain points, understanding the equipment deeply is really what allows us to, forge the path of the product to the right places. Because by hearing the challenges of our users, that's what basically drives the next feature, the next version, and so on. So it's very critical for us.
Yeah, and we also work closely with subject matter experts, right? And they're actually part of our offering in the places where our customers require that they can step in and give them support that they need.
Correct. I mean, imagine that you had some. Not you, but somebody has some illness, some sickness, and they went to the smartest doctor, but that doctor was just completely AI, 100%, no human being. Would you go to such doctor? I mean, it's pretty scary, and for conservative industries, even more, right? So our concept is, okay, yeah, we have the AI, we have the automation, we have the system, but if you want to consult somebody, we have a real human being, as you said, a person with 25, 30 years of experience in that industry, in these machines, that you can speak with, you can consult with, you can ask any questions. How do I calibrate my VSD switching frequency? Why did you recommend this one and not that one? My motor base is a bit different. What do I do? So any question, and it gives this personal touch that I think is very important, again, in the relationship building, into putting the trust into the system and the methodology and so on.
Yeah, and it's actually it comes to it brings me to the next question. Is there was a lot of debate around AI implementation and AI usage in mining sector or across the industries, and the whole topic of digital transformation, Industry 4.0, and everybody was extremely scared of AI replacing humans. But what we actually see in the mining industry, from our experience, is that there's shortages of manpower. Mining companies struggle with hiring professionals. They always run those extensive campaigns on LinkedIn and everywhere of trying to hire anyone from operators to mining engineers. And we always say that AI is never going to replace mining experts. It's going to enhance their work. It's going to enable them to do more with less. And this is also the topic that you speak about with subject matter experts and AI and how they should be working hand in hand.
Correct. These are efficiencies. I mean, it's doing more with the same teams. Imagine I would take email from you. I would take, I don't know, Microsoft Word or PowerPoint or, a smartphone, the basic tools that you use. So the same teams would just be less efficient. They would accomplish less. And what we try to do is we try to find a way for that incredible technology that everybody are speaking about. How do we a bit forge it into the place where it can be used by miners? Exactly because of the reasons that you've said. So to take these overworked teams and to make sure that, they can return home on time, that the reliability of the equipment is really where it should be, and it doesn't break over Christmas or holidays or weekends. Because obviously it has a financial impact. Many of these failures are millions of dollars literally per event. And obviously the maintenance costs and the replacement, but really also looking at the quality of life of these people.
Yeah.
Right? I mean, the vision eventually is autonomous operation that can take care of itself. The people would still be there, but they're going to handle the complex challenges, the more interesting ones, the ones that require their focus and so on, and basically not do all the mundane stuff that AI can help with today.
And they can be more sure of their safe environment than
Correct.
Before.
Which is major.
Which is a major topic also. So you were talking about making the operations of mining sites more efficient. Can you share any success stories, recent success stories of DataMind AI in the field, and maybe share some cost savings numbers and case studies? Sure.
So I can give you several examples. One of the examples that we have is from a site in South Africa. It's a precious metal site, so they don't have a lot of throughput in terms of tons per hour, but every ton is very valuable. In their site, they estimated every hour of downtime roughly $20,000 per hour. And every few weeks...
That's not the highest number in the industry.
That's not. In gold, you see higher. Obviously, iron ore can be through the roof with more than $100,000 per hour. But imagine that that's per hour, right? When a failure happens, it's not an hour or two of downtime. You're mostly looking at least 4 or 5 hours. So you're still getting to numbers that are in the hundreds of thousands of dollars per failure. So it's pretty substantial ones. And unfortunately, the failure doesn't happen once a year. You see lots of failures on site. In this case, they had repeating mill stoppages, basically just because of overload on their site. And they were keep on replacing, the equipment of the mill, its motor and gearbox and so on. And when we installed the system, we've seen that the root cause, what we discussed, was actually not even there. So the root cause was upstream. They had liner wear in their crusher that just caused oversized ore. That obviously went downstream to the mill. And when it accumulated, after a few hours, the mill just tripped on over.
And also imagine over time the overload in the mill when
obviously it wears out the components, of course.
In suboptimal conditions, then it.
So now when we now monitor this entire process and we saw the root cause, basically our cameras, one of their features is to size the ore, and they just saw this trend where the oversize. So we know what is the crusher gap. And we know what portion of the ore needs to be monitored, right? Let's say my crusher gap is 200 mil. I'm looking at all the ore that's more than 200 mil, and I'm looking at how much of it is there. And it basically gives you a very easy to understand trend where when you see it increasing, you immediately know that something is wrong. It doesn't take a minute or two, but you have plenty of time to react.
Mm-hmm.
And in their case, the head of maintenance was now completely data-driven. They had the trend. He got an email also alerting it. Now remember, we have an evidence, so he also got a GIF showing these are the rocks that we found that are oversized, and you can see their quantity increasing. So it's a pretty intuitive, deliverable, a pretty intuitive result. And he sent the team to check the crusher. He insisted. They said that they just maintained it and nothing there needs to be done, and he just insisted. And when they actually went there, they saw that the liners were completely worn out. They replaced them. The ore went back to normal, and now every time that it happens, they just proactively go ahead, replace the liners, calibrate the gap, whatever it is. And we've been deployed there for a year now and just didn't have this ever since. So imagine it's millions of dollars, because even if one of these events is roughly, let's say 100,000,
multiply it by 5 or 6 a year.
Exactly. So you get to really substantial numbers, and that's, just this one phenomena of that, crush or liner wear causing the oversized door, causing the mill downtime.
And all these actually machines, like critical equipment.
There is no redundancy in mills. Yeah, you have, what mills you have. These are your mills. They work 24/7. There is no redundancies there. So literally every minute of lost, of mill downtime is just lost throughput.
It also sounds like the mill or the conveyor or the crusher can have also longer life cycle before they get replaced eventually, because mills are also like served for life. They serve from 10 to 20 years, right?
Of course, if you have oversized door, it was obviously wear out your belt. It would wear out other downstream components. We also track the alignment of the belt. That also causes belt wear. The misalignment causes belt wear. It causes pulley wear and others. So yeah, you get basically longer life of the equipment, which means less maintenance, less effort, less maintenance costs as well.
It might be extremely rewarding to get that feedback from the site where the team reports back saying, no, we just maintained that part, it should be fine, and then despite that,
eventually
they look into that and they see that data doesn't lie.
Data doesn't lie, exactly. If you show the right evidence to the right person, eventually it is what it is. And they take it from there and they handle it beautifully. They have tons of experience, and it's amazing the impact that you can do, because imagine we're not deployed over 1 or 2 machines. We're deployed on dozens of machines, sometimes more than 100. So the impact that you do to a site, you literally see it year by year, and we track these KPIs. Mm-hmm. How many machines were red? How many machines were orange? How many failures were just prevented because you know about them before that? And you keep these KPIs, and they add up to super substantial numbers.
That is really incredible, and I wish that concept of our solutions, or the types of solutions that are similar to ours, I wish the concept of them would be less threatening to mining teams on the site, to maintenance teams on the site, and because I remember once the feedback that we got of a specific team mentioning that they're afraid that we'll be taking their jobs, but the idea is definitely not to take their jobs. The idea is to make their jobs easier and make their lives easier and more comfortable, and this example just shows to prove it, which is really, really incredible. So you mentioned that the DataMind AI is extremely easy for implementation. How does a typical implementation scenario look when you come to the new site, like from just initial discussions to the implementation, and how do you integrate with existing solutions on the site that the teams use?
Sure. So it's a good question. First of all, as you said, we come to site, and that's very important. Not many companies do it. We come physically to site to meet the people and to meet the personnel, and first of all, define what is critical for them. Are these the mills, the crusher, their stackers, these conveyors, some ventilation fans, slurry pumps, whatever it is. And we basically build a list. This is the equipment that is critical, and these are the quantities. It basically takes maybe 2 or 3 hours on site, that's it. And from there, we go on and do our homework, where we have a methodology of what sensors are actually required for that equipment, right? So we know that if we monitor a mill, we deploy oil sensors here, vibration sensors there, current sensors here, and temperature, and so on. And we build a very elaborate table of what sensors types are needed, and for each machine exactly where. That's homework that we do. And now remember that we know what sensors are on site because we've been there. So we also know what sensors exist and what sensors are new and need to be deployed. Basically, the site, after these 2 hours of visit, gets a short document of what we call implementation plan, saying these are the machines and these are the sensors that need to be deployed, and that's it. We schedule the deployment together with them. We have local teams really everywhere, Australia, South Africa, South America, Europe, and so on. The teams already build what we call the kits, right? So our kits are sensors that are connected to gateways. The gateways send the data to the cloud. They pre-assemble everything. They ship it to site. and they come to site to mount everything on place. No shutdown is needed for that. After all the gateways and everything are mounted, basically they connect the sensors. Machines that are not behind guards, they can just connect the sensors whenever it's convenient. Ones that are without behind guards, they just use kind of mini shots, a few hours of downtime, of shots to connect them. And that's basically it. The entire process takes a few days, maybe a week, depending on how many sensors are required. And that's it. I mean, literally the system is up and running the next day. They can have full visibility of the equipment. They see all the diagnosis, what equipment is healthy, which is not, to what degree. We have 4 degrees of urgency. They get a very specific diagnosis of that specific gear mesh or that bearing or that motor is loose, whatever it is, very specific location. And they have complete access to the data, right? They can go through the entire data, both their existing one and the ones that we deployed. They have full visibility of everything, and they just take it from there.
Razor Labs customers are located across the globe, from Australia to South Africa, South America, North America, and Europe. How do you manage the global operations? How do you manage to provide support to the customers around the globe?
So for implementation, as we said, we have local teams. So we have actual local teams. Some are ours, some are just partners that we use that are completely trained on the system, and they perform the installation. And for this support, our experts are, again, globally in all time zones. So we have weekly sessions with almost every site. And these experts that are in the same time zone, they just get on the call and they answer any questions that there are. And yeah, it means that we have literally teams on every major time zone in the world.
And in terms of integrations with other existing solutions on the mining side, how does DataMind AI integrate with those?
So that's a good question. First is SAP. SAP basically provides the maintenance data. It's all the records of both the work orders, that's majorly, and obviously the notification. And what we came to understand is that presenting the maintenance work inside our system, along with the condition monitoring data, is very beneficial. And I'll explain. So let's say you see the past trends, you see the past diagnosis. If you put on top the maintenance data, it allows you very intuitively to just see the efficiency of your maintenance. You can see, okay, I was, for example, red. I performed maintenance. Did I go back to green, or was it to yellow? That's number one. Number two is, okay, I see now, let's say, bearing deteriorating. Should I replace that bearing, or should I replace the motor? If I have it in the same place, I can just look, when was the last time I replaced that motor? How many hours did it even work since then? And that's very major, in what load? Because obviously if it was overloaded for all of that time, I need to replace it sooner. So all of these parameters, when they're in the same system, they give you lots of benefit that, yeah, you can do that manually, but it's so much more work, and most people don't. And we present actually the maintenance data from SAP. So we ingest the work orders. We read them, right? The system automatically reads them, identifies exactly what is the equipment according to the functional location and so on, and it presents it in the same place. So you know how efficient your maintenance is, and you know exactly what should be your next maintenance steps.
That's beautiful. Yeah, when it comes to delay accounting methodology, where mining sites look at the entire calendar year and then they divide it into those groups of times where you have planned shutdowns, unplanned shutdowns, and all those times when equipment is functional and when equipment is not functional. And DataMind AI basically enables them to increase the time that the machines are active and can be relied on operating efficiently.
Correct. I mean, if you look at the KPIs, one of the major, or two of the major ones is one, unscheduled downtime, right? If you prevent breakdowns, pretty straightforward, you have more uptime. But the second, which is not less interesting, is the planned downtime. And the concept is, number one, if your machine is healthy, maybe we do not need to maintain it. Or maybe we can postpone the replacement of that component because we don't see any deterioration. Right, so there's lots of tasks that can just be prevented, and now instead of having, a shot of, 9 hours, it can be reduced into 7 or 6. Or if you have longer shots of 2 days, maybe it can be now a day and a half. So this is pure new throughput, just like unplanned downtime that just causes higher throughput of the entire site.
Yeah, and also the ability to, I think, kind of centralize all the maintenance into one planned shutdown. I think it's critical and crucial for the mining side. It just makes everything more efficient and more streamlined.
Correct. I mean, even if you already perform some planned shot, because you know now what is deteriorating, it becomes surgical. You don't go ahead and you inspect everything, replace everything, and so on, but you now know exactly, so I need to handle this specific bearing in that specific motor or whatever it is, and all the rest, it's just ready to go. I don't even need to inspect it because I know that it's healthy for sure.
Yeah, it just becomes extremely effective, which is a major significant benefit. There's a lot of conversation around more sustainable operations, and while they talk about a lot of initiatives of conscious mining and everything that has to do with the resources extraction, there are also a lot of low-hanging fruits that can be addressed. Specifically with DataMind AI. How does DataMind AI affect sustainability of the mining site?
I think that we need to start with the bottom line. Eventually, we need mining, right? I mean, all of the critical elements in our cars, in our smartphones, all the electronics, they come eventually from mining. And now the question exactly as you asked is, how do we make it more sustainable? How do we really make it more efficient so that the energy usage, all the waste, any pollution and so on is really minimized to the bare minimum it could be. And I want to give maybe one example that is very substantial and gives a very good intuition. Let's speak about pumps, right? So pumps are responsible for a huge portion of the overall world, power consumption. There's so many pumps. We have sites that have more than 100 pumps. So maybe each pump...
Just in mining, but pump is also crucial equipment in all industries.
Of course.
Energy, oil and gas, everything. Yeah.
But even if I'm taking some processing plant or a mine site, whatever it is, yeah, obviously the mill would take more power than a pump, but how many mills do you have? 2, 5, 7 if it's a very large site? You can have more than 100 pumps. And all the power consumption there accumulates to gigantic numbers.
Wow.
And imagine we need to produce that power so that our power station causes, these are called, the second circle of pollution in order to just produce this electricity.
The energy that's going to be wasted.
Exactly. I mean, you need to produce this electricity which causes pollution. So now the question becomes, how do I become more energy efficient? Now, obviously in pumps, one of the critical parts are the impeller that pushes the fluids. And when we look at operations that are high temperature, high acidity, and so on, this impeller with time wears out. It wears out, right? So the pump operates. If it would have drawn the same amount of electricity, it was just not push enough fluids. So what happens is that with time, the pump will take more and more and more and more electricity to push the same amount of fluids. It's very hard to monitor. Not all pumps are simple. Some are complex. Some would change, change speed, change all the operational parameters change, and it's very hard to monitor. And what we do is, in this case, for example, we monitor what we call the performance of the pump. We monitor how efficient is the pump. We look at the pump curve specifically. I'm not going to get into that.
Yeah, I remember that chart, the technical one.
But basically, what we ask is how efficient is it, and if it becomes not efficient enough, we indicate to the site team that will go ahead and will replace the impeller of the pump or the entire pump.
Can you estimate the percentage of wasted power that is used?
It can be 10% in
10%.
some cases, but it can be also 25% in others. It's dozens of percent. It's not negligible. And now you multiply it by the amount of pumps you have. You multiply it by the amount of sites. And it's 24/7. Imagine it's working all the time. And these are, from really 100 kilowatts, and they can go up to a megawatt. So it's huge losses. And that's just the pumps, right? We didn't discuss fans. We didn't discuss filters that can be clogged and so on. So it's basically equipment that can just take much less power to perform the same task. And you cannot expect the team on site to have, continuous monitoring of everything because they're so overworked. They have so many things to do. But with these kinds of systems like DataMind, we monitor everything 24/7, and once there is some what we call performance issue, we alert about it, and they can just handle it. They can clean the filter, they can replace the impeller, and so on, and reduce dozens of percents of their
that's the
energy
uniqueness of the
consumption.
solution because I heard you once speak at iMark event, and you were interviewing with someone on the ground floor, and you said a sentence that really stuck with me for the last 2 years. You said that the fact that you know that the failure is coming doesn't mean that you know what to do about it. So even if you were to be able to diagnose that there is an extra power usage by a specific type of equipment, it theoretically doesn't mean that you automatically know how to fix
Correct.
it. And that's the beauty of root cause analysis that DataMind AI runs along with the prescriptive actions, where basically on the dashboard you see this is the problem and this is what you have to do.
Exactly.
Because we heard from our customers, I was part of this conversation as well a couple of times when they would address other solutions. They say, we would get an indicator that something is wrong with the equipment, but then we would have to go open up the machine and try to understand what we want to do about it. And it's not always easy to do, and it's not always possible. And that's the beauty of DataMind AI, that you get those indicators and prescriptive actions. What is your vision for the future of DataMind AI and Razor Labs in the next 5 to 10 years?
Oh, wow. So our goal right now is to scale up. It took us 10 years to build this technology. And I feel that in the last few years, the product today gives an answer to really, painful challenges that this industry has. We started in Australia, but then we expanded to South Africa and to others. Our goal is to expand as much as possible to more geographies, new continents, and so on, to really make sure that the impact of what we've built, of this amazing R&D, is completely fulfilled. We're now a publicly traded company. Our goal is to get to NASDAQ, right? So to at least double list there. So really to scale up. I mean, to scale up to get to hundreds of sites and then thousands of sites. That's our goal.
So we discussed the vision of Razor Labs for the next 5 to 10 years. Looking at the future, which challenges do you foresee in that industry adopting AI solutions or innovation specifically?
I think that from our experience, one of the most important factors is, on the one hand, you have the team on site, right? There are people that are overworked, right? They're overloaded and so on. And on the other hand, you have these, cutting edge technologies that will give you value, but you need some, what we call an ambassador, or some champion, exactly, to go with you hand in hand and to make sure that they're really assimilated. From our experience, the best impact were with companies where we had this champion, somebody that understood the technology, somebody that could have the resources to push it forward in the organization to get through this, initial challenge up until when it actually delivers the value. And I think that my message to sites is to have this person, because you cannot expect, a maintenance engineer or a superintendent that has so many issues on site and so on to start engaging with a technology company and make this journey together. Even though it's so easy today, even though it's much shorter, I think that having these, what we call digital transformation leads or innovation leads and so on, that proved from our experience to be one of the most prominent factors.
Yeah, it seems like such a challenging position within a company, because on one hand, you need to be able to get the team on board. On the other hand, you have to implement the external vendors and you have to get them working together. And it seems like you have to push a lot of strings within the organization to make it all happen.
Exactly.
And bring it into reality. Where do you see the future of AI technology in the next decade, particularly in mining industry or in other asset-intensive industries?
Wow, it's a very tough question to try to anticipate the future.
Yeah, we'll check back in 10 years and see whether your forecast was correct.
So I think that even if I'm looking at the next few years, we do see a trend, right? I mean, if you take ChatGPT, for example, that most of us used at least once, it goes to the direction of a kind of a personal assistance, where you would have maybe one that's more personal for you, but also others for smaller tasks, right? One, for example, in Microsoft Teams that would, record your session, transcribe them, and analyze the action items automatically. Others would help, for example, doctors, and others would have basically lawyers and any others. So I think that we're going to that direction.
Personalized automation.
Correct. And personal, not only in the sense of every person, but also in the sense of every task. Basically being able to automatically analyze also enterprise data, not only publicly available data. So imagine having ChatGPT for your company. That's, I think, a direction that is very prominent in my view. I also think that today, if you look at OpenAI and their direction, they're already going to this direction by allowing you to create custom GPTs, exactly, with your data and so on. And I think that now we should think about how does this connect to mining, right? So if you look at the trends in mining, these trends in this sector at least around automation, right? Automation, how do we make process more autonomous? How do we make larger operations, right? Because we need more and more mining, but not necessarily we have more people, right? So how do we make larger operations with the same amount of people? And now we try to connect these. So the way that I envision it is, we have all this data, but now we don't look at raw data, like what SCADA gives you, but how do we give the bottom line insights? So we deal with condition monitoring, but other companies might look at safety or process optimization or mine planning and so on. And basically the goal is to take these huge amounts of data. So imagine like ChatGPT, but not for text, but it can be geological data, it can be operational data and so on, and give you the bottom line, kind of be your personal assistant to help you get to your goal faster, more efficiently, and so on. I mean, when I use ChatGPT today, it does not replace me, because I'm still the creative one, right? I tell it what to do, but instead of taking it, I don't know, a day, I can now do it in 2 or 3 hours.
Yeah.
So imagine the same thing for safety, for process optimization, for mine planning, for condition monitoring and predictive maintenance. That's my vision, where the goal is that eventually the person focuses more on the creative part, on determining what is the North Star, where should we go and how should we do it. And then the easier tasks are performed by the AI.
Yeah, because I think it's true that you're so right that people don't necessarily understand how much mental load,
Exactly.
how much mental effort it takes to just follow simple schedules or follow simple protocols, or even just, to create or generate, do the daily tasks. It takes a lot of mental workload that is kind of stolen from creative tasks, from really deep thinking, from planning ahead, and from strategizing, which is, essentially what needs to be done.
And people that worry about being replaced by AI, eventually, even if you use today the most cutting edge model of OpenAI, and you try to get the model to answer, questions that are creative, you immediately see that it's not there. It can help you with the simpler tasks. It can help you with the more well-defined, but once it's an open question, there it becomes much, much harder in any topic. So that's why the goal is to keep these tasks for the people and keep the simpler ones for the AI.
What is your personal motivation that helps you to continue innovating, thinking about innovative solutions, and finding new solutions for existing problems?
Wow, that's a very philosophical question. I guess that the answer is eventually when we retire. That's the way I think about it. We all look backwards into what we have done, what have we accomplished, and so on. And we spoke about impact, right? That's what we're trying to do, right? We try to make every day count. We try to make sure that if we build something, it has the largest impact. We changed, the operation in 1,000 sites. We reduced, global emissions by, 1 million, whatever tons of CO2, whatever. What drives me is knowing that we make an impact, that we change lives, that we impact, the environment. Mining is so profound in our day-to-day. I mean, we literally use its products every day.
It's the most basic.
I mean, you cannot
Yeah.
live without it. And we saw a real opportunity to make an impact that's not, by 1% or 2%, but by, I don't know, 20, 30, whatever it is. And that's what drives me, that I know that in X amount of years, I'm going to look backward and ask and say, wow, I really changed something with this amazing team of people that are basically my friends. And it's quite a journey to make it.
It's true. We are actually really, we are friends in the company. Yeah. I have to mention one anecdote that, throughout the years, the Razor Labs went through different shapes and forms. People came and people left, and which is normal. It happens everywhere. People come and people leave. But when you got married last summer, I saw so many people that used to work for Razor Labs and don't work for Razor Labs anymore for various reasons. And they all came to your wedding because they are your friends, ultimately.
Exactly.
Which to me was a testament of cultural environment and the culture of Razor Labs and the general vibe. And yeah, it's true.
I think it's worth saying that we have amazing teams of people, in R&D and really everywhere, R&D and product, and people in really, marketing and sales, and really in all. No, it's amazing to see because it's a very interdisciplinary task. Mechanics, obviously, and common. So many people of very different backgrounds come together to create this amazing impact together, and it's a team effort, and it's just amazing to see, and it's amazing to be a part of it. It's amazing to wake up every day to this, to this. And to know that in X amount of years, as I said, I'm going to look back and say, wow, we really changed something. We really made an impact.
Yeah, correct. We're an amazing, incredible team. And that's also something that keeps me personally going every day. What advice would you give to young founders or starting founders who aspire to make a global impact with their technologies?
Wow, a very extensive question. I would give several advice. Number one is meet clients all the time.
Mm-hmm.
Know your clients like the back of your hand. Know their pains, their challenges, their everything. Number two is, and it comes with the first, literally build the minimal thing that you need in order to meet these clients. Because once you're going to meet the first clients, everything is going to change. And after everything changes, build the minimal thing to change it and meet some more clients. Be in the market all the time. That's very critical. Unfortunately, I did see many incidents of, entrepreneurs going into R&D of years, completing it, and then finding out that the market just doesn't need the
No
invention.
product market fit anymore.
So that's very, very important. And I think that the third is be strong. You're going to fail a lot. It's a part of the process. There isn't an option. It's very rare, and it's a matter of chance of succeeding from the first time. So don't be scared about it and pivot, right? It's okay. You got some feedback, pivot to the place where you see that the market is actually, willing to accept that kind of solution. So be strong. Pivot when you need, and just be optimistic.
Yeah.
I think it's a very important part of being an entrepreneur.
And I would also add, get equipped with a good sense of humor, because you will need a lot of it.
Self-humor, yes.
Yeah, this is actually something that is very similar between you and Raz. You guys laugh a lot at yourself, which is very fun important to watch.
Yeah, so that's
true. And last question, your favorite piece of mining equipment?
I think, it's hard I have two in my head.
Okay, you can say two.
Yeah, so I think that one is a pump. No, really, and I'll explain why. It seems trivial at first.
But they're everywhere.
No, not that, but it seems trivial at first, and then you understand how many variables are there. I mean, I think that a pump requires from our end today the most diverse set of sensors.
Wow.
It's amazing. I mean, We use their vibration, we use pressure, we use flow, we use tachometer, we use current of the motor. I'm not sure there is a single piece of equipment, well, oil if there's a lubrication issue.
But not cameras, for example, no?
Not cameras. That's the only one that's not used there. And it's incredible. And they're all interconnected.
Mm-hmm.
And in many cases, it's mandatory to have all of them. In some, well, not all the time, but in some cases. So it's really beautifully complex, I guess. So that's why I chose this one. And I think that the other one is, as you said, the visual part of the conveyor. I mean, when we today, meet with customers, existing ones, new ones, the wow effect that you get from showing the visual analysis, all the measurements, all the phenomena, all the, we look at belt wear, so many
I led
types
that
of
part to
damages.
the editing, so audience can understand what you're talking about.
It's super cool, and there's so much, we can also do in the future. We're now looking at belt wear and different damages to the belt, so many phenomena, and it's just, a single piece of equipment, and so much you can do. So that's, I think, also would be in the list.
Amazing. Thank you. Michael, it was really fun to have a conversation with you today. Thank you so much for
Thank you.
recording this episode with me, and stay tuned. I'll be back.